Okay, so today's video is on derivatives and particular solutions, and let's see if we can make some sense out of what this means. If I take the derivative of this very first y equals equation, this one, and I take the derivative, I get y prime equals 2x. Now, the original equation, if I graph it, is up at 4, and it's 1, 2, 3, 4. And so it goes something similar to this. I have a big fat drawing tool, so it's a little bit hard. The second one, when I take the derivative of that, is y prime equals 2x. Also, now the original, this one, when I graph it, goes something like this. Goes through at 1. It was supposed to hit at 1. Didn't quite make it there, but the gist of it. The third one, let's go purple. The third one, when I take the derivative, is also y prime equals 2x. Y'all can do that with me. And the derivative, but the original is 1, 2, 3, 4, 5. And it goes up in a similar shape as this. Now, this is derivatives. If we think of derivatives, we know that slope. Well, the basic slope of all of these, all three of these, is they all have the same basic slope. So they're going to all have the same derivative, the same basic slope generator anywhere. Well, what happens when we go to take an integral, and let's say I want to work backwards, and that's what an integral is. So if I take the integral of 2x dx, and I want to work backwards, the problem is I don't know which one of these I have. Do I have this one that's down here at -5? Do I have this one that's up here at 1? Do I have this one up here at 4? I don't know where any of them are. And so when we take an integral, we undo it. And so to take the derivative, let's walk through this rule one time really carefully. When I take the derivative, so I have x squared. The derivative of that, I take the 2 down front, so I have 2x, and then this power drops by 1, so 2 minus 1. You already know this. We've been doing this. That's the power rule. Well, if I start with this one, and I have 2x, and I want to integrate it, it becomes 2x. I increase, so the 1 now becomes a 2, and I divide by, I undo this, this property right here. So I'm multiplying and then subtracting. Well, in this case, I'm adding and then dividing. So as you both all know, that's going to cancel. So the integral is x squared. Well, that's what I have basically right here. All these are x squared. That's the parent function. So what I'm missing is what we do is we put a great big plus c. And that is going to be so important because that plus c means it's plus some constant. And that constant could be a 4. That constant could be a 1. That constant could be a -5. And so that's what we mean by particular solutions. So I will give you some examples, another example, but we're going to plug in and see if we can find what these should be. So we're going to start with, and I'm going to try not, dy dx equals 3x to the -4. And we want to find a general solution. And what they're asking for is for us to take the integral. Now, I forgot to pause and say, get out your notes so we can write this down and do this together. So pause while y'all all get out your notes if you don't have them out already. Now, in order to take, I'm going to assume you're back now. In order to do this, in order to get it, we're going to, when we end. Okay, so now we're taking the integral. So I'm going to take the integral of this side and the integral of that side. The integral of dy is y equals 3x to the -4, but I increase, so I'm going to add 1 and divide by that new exponent. So I'm going to divide by -3, which Oops. Undo. It's not going to let me undo for a moment, so I'm going to erase my equal sign. Because what I forgot to put right at that moment is plus c. So when I simplify this, this is going to be 3 over, that's going to make it negative 1, x to the negative 3 plus c. Do you have to put the negative 1? No, y'all already know that. So this is the general solution at this point, y equals, and we're going to try another one. So let me get my example and we'll try one. Okay, one more example, and then I'm going to let you practice some and see if y'all can work it out together, and then see what you can figure out. So the integral, and this doesn't say y equals on the other side, but 1 over x to the 5th dx. I'll say it again, the integral of 1 over x to the 5th dx. So the first thing we want to do, just like when we do derivatives, is we want to do a rewrite. And so this becomes the integral of x to the negative 5 dx. Now, when I take the integral, I'm going to add 1, so that's going to be x to the negative 4, and I'm going to divide by that number. And immediately, right here, put your plus c. And that comes because we don't know what that number was when we started. We don't know if it's a 5, a negative, a million, 2, 0. We don't know, but it could be anything. These are called antiderivatives. And then if there's any simplifying to do, you can then simplify. So some of you would like it rewritten as this, with 4, and then we drop the x to the bottom. Do you have to? No. We all know how that works. Plus c. This part right here, that plus c, is going to make us and give us numerous headaches, but that is your answer. So that is how you work on, and these are antiderivatives or general solutions. Good luck, have at it, and I will leave you a key.